Honey is one of the oldest and most treasured natural foods on Earth, created by millions of tiny insects working with astonishing precision inside complex hive systems. Yet few people ever see the incredible journey behind a single drop. From bees gathering nectar in fields to massive honey factories filtering, testing, heating, blending, and bottling millions of jars every day. And today on the How Factory, we're going deep into that world to show you how honey is collected, filtered, and bottled at enormous industrial scale, revealing a blend of ancient biology and modern engineering that produces billions of pounds of honey every year. It all begins far from the factories in sprawling landscapes filled with flowering plants. Orchards, wildflower meadows, clover fields, citrus groves, acacia trees, and countless other nectar-rich environments. Honey production starts with honeybees, primarily the European honeybee, Apis mellifera, which forage across large areas, visiting millions of blossoms to collect nectar. Worker bees suck nectar into a special internal honey stomach, mixing it with enzymes that begin the transformation into honey. Back at the hive, they pass this nectar from bee to bee, thickening it through repeated digestion and evaporation, and finally depositing it into honeycomb cells. Bees then fan their wings to reduce moisture even further until the liquid becomes thick and stable, at which point they seal the cell with a layer of beeswax, locking the honey inside like a natural vault. Beekeepers monitor these hives throughout the season, checking for the right moisture content, brood patterns, colony strength, and overall hive health before honey can be harvested. When frames are full and capped with wax, it's time for collection. In large-scale operations, thousands of hives may be harvested at once. Beekeepers use smokers to gently calm the bees, remove frames, brush off excess bees, and load supers, boxes containing honey frames, onto trucks heading to extraction facilities. Here the balance between natural agriculture and industrial processing truly begins. Inside a honey house or honey extraction plant, the first step is uncapping. Frames arrive coated in wax seals that must be removed to free the honey. Automated uncapping machines use heated blades or vibrating knives to slice the wax off each cell with millimeter precision. The wax falls into collection trays below, later refined into candles, cosmetics, or foundation sheets for new hives. Once frames are uncapped, they are placed into massive stainless steel extractors. These extractors spin at high speeds, using centrifugal force to fling honey out of the comb. Large extractors can hold dozens of frames at once, spinning horizontally or vertically, depending on design. As the honey flies out, it drips down the sides of the extractor and collects at the bottom, flowing through pipes into settling tanks. The honey at this stage contains small wax flakes, pollen particles, and tiny air bubbles, so it moves next into filtration. But before filtration, honey must flow at the proper viscosity. Some plants slightly warm the honey to around 35 to 40 degrees Celsius, not to cook it, but to match natural hive temperatures, making filtration smoother while preserving enzymes and nutrients. In settling tanks, gravity causes heavier particles to drop to the bottom and lighter wax bits to float. The clean middle layer is drawn off and sent through fine filters. Industrial filters, often stainless steel mesh screens, microfilter pads, or food-grade nylon, remove remaining impurities down to the micron level. Some honey is ultra-filtered, removing nearly all pollen for clarity. Other honey is gently strained to keep natural content intact. The level of filtration varies by brand, market, and regional regulations. Once filtered, the honey enters massive storage tanks capable of holding thousands of gallons. These tanks maintain gentle warmth to keep honey flowing, while also preventing crystallization during storage. Quality control teams take samples from each batch to test moisture content, usually between 17% and 19%, as well as flavor profile, color grade, sugar composition, glucose, fructose, sucrose, pH, enzyme activity, presence of contaminants, and indicators of botanical origin. Specialists analyze honey for ultra-trace compounds that reveal whether it came from clover, wildflowers, acacia, manuka, orange blossom, or other sources. High-end honey factories blend batches to maintain consistent taste and color year-round. If moisture levels are too high, honey risks fermentation. If too low, honey becomes too thick to bottle efficiently. Once the honey is finalized, it flows to bottling lines. Modern honey bottling plants look like high-tech beverage factories. Automated pumps move honey into dosing systems connected to filling machines. Containers, glass jars, plastic squeeze bottles, bear-shaped bottles, tubs, or bulk drums arrive by conveyor and are cleaned, sterilized, and aligned under nozzles. Honey flows in precise amounts controlled by sensors that ensure each container hits exact target weight. Some lines fill 200 bottles per minute or more. After filling, bottles pass through capping machines that screw on lids, heat seal foil membranes, or snap on plastic tops. Then, labeling machines apply barcodes, batch codes, nutritional information, and branding. Sometimes using sleeve labels heat shrunk perfectly onto containers. Cameras scan each bottle for defects. Missing caps, mislabels, underfilled or overfilled units, or contamination. Any flawed products are removed instantly. Next, packaged bottles move to boxing stations. Automated robots arrange bottles into cardboard boxes, fold and glue them shut, and stack them onto pallets. Pallets travel by forklift or automated guided vehicles into climate-controlled warehouses where honey rests before distribution. Temperature and humidity are carefully managed, even in storage, because honey naturally crystallizes over time. Different types crystallize at different speeds. High glucose honeys crystallize quickly. High fructose honeys remain liquid longer. Many honey factories use controlled warming tunnels to gently re-liquefy crystallized honey before bottling. These tunnels use warm air or water jackets to heat honey to hive-like temperatures without damaging quality. For creamed honey, the process is entirely different. Creamed honey is made by controlling crystallization intentionally, using seed crystals to encourage small, fine-grained crystallization that creates a smooth, spreadable texture. Industrial creaming machines slowly churn honey for hours or days at precise temperatures, producing a soft, uniform product popular in many countries. Meanwhile, honey destined for industrial use, bakeries, beverage companies, food manufacturers, is packed into large drums or tote containers holding hundreds of kilograms. These bulk shipments feed massive food production lines worldwide. Behind all this processing lies a global network of beekeeping operations. Commercial beekeepers often move hives seasonally for pollination contracts. Almond orchards in California, blueberries in Maine, canola fields in Canada, helping agriculture thrive while producing honey as a secondary benefit. Beekeepers must manage pests like varroa mites, monitor hive nutrition, prevent diseases, and ensure colonies remain strong enough to produce surplus honey. Wax, propolis, royal jelly, and pollen are also harvested as secondary products. At honey factories, quality control goes beyond basic testing. Labs check for adulteration, adding corn syrup or sugar syrup, which is illegal and detectable through advanced chemical analysis. Nuclear magnetic resonance, NMR, isotope ratio testing, chromatography, and pollen analysis help verify authenticity. Some high-end brands test every batch before release. Sustainability plays an increasingly large role in honey production. Many companies support pollinator-friendly farming practices, reforestation projects, wildflower corridors, and reduced pesticide use. Factories recycle wax, reuse heat through energy recovery systems, and minimize water consumption. Packaging innovations, glass, recycled plastics, paper-based materials, reduce environmental impact. Honey is one of the few foods with an almost indefinite shelf life. Its low moisture content and acidity inhibit bacteria and spoilage. This stability makes honey ideal for long-term storage, emergency supplies, and global shipping. When honey arrives in stores, fresh jars are placed on shelves in clean rows. Customers choose based on clarity, color, floral origin, or brand reputation. What looks like a simple sweetener is actually the end result of millions of bees, thousands of flowers, hundreds of beekeepers, and advanced industrial machinery working together. From nectar gathered in meadows to frames lifted from hives, from high-speed extractors to precision filters, from giant storage tanks to robotic bottling lines, every step of honey production blends natural biology with human engineering. And by the time you squeeze honey onto toast or stir it into tea, it has passed through dozens of processes ensuring safety, purity, flavor, and the unmistakable golden color that people have cherished for thousands of years. That is how honey is collected, filtered, and bottled on a massive scale. An incredible journey powered by nature and perfected by industry. Thanks for watching The How Factory, where we uncover how the world really works. Don't forget to like, subscribe, and join us next time for another deep dive into the hidden systems behind everyday products.